Alright, so for this video, I'm going to go over something called a partition of a sample space. This is actually an important concept, and important enough that I chose to make a video about it. And normally this video would be actually really short, but I'm going to not only tell you what it is, I'm going to try and give you a sort of tangible impression as to why it's important, because it's important in mathematics and probability to actually care about these things in some sense. If you don't, then it's going to be really hard to remember them. Okay, so I'm going to start with a definition. So suppose we have a bunch of sets, E1, E2, possibly countably infinite, such that their infinite union is equal to S and their pairwise disjoint. Then we call this collection of sets a partition of S. Now, when I say collection of sets, I just mean a set of sets. It's set theory, everything's a set, so on and so forth. So don't get confused with that, but sometimes using two different words makes me sound smarter. So, okay, so now we have the definition. What does it really mean? What are we really doing here? Well, suppose this is our sample space, S. So this bad boy here is S. And suppose we have cut S up. 1, 2, 3, 4, 5, 6, 7. So we've cut it up into E1, E2, E3, E4, E5, E6, and E7. Now, if in your mind you're thinking of some real numbered example, there's no overlap on any of these borders, okay? And so EI intersect EJ is going to be empty for I not equal to, I not equal to J. Okay, so now... Alright, so now we have a partition of S. How could this possibly be useful? Well, suppose we have a set B that we want to actually know about. What is the probability of B? Well, what we can do is actually use our partition and define B as the union. It's not a U, it's just a U without the little tail, I equals 1 to 7 of B intersect EI. Okay, so that is equal to this probability, because B is just the union of all of the different pieces, okay, that are cut up. So these are the different pieces, and if you add them all together, you get B. Okay, now they're also disjoint, so we can use that axiom of probability that tells us that that's the sum of the probabilities of B intersect EI. Okay, great. So again, we've written out an equation, but we don't yet care about it. Okay, so why could this be actually something of interest? Okay, so I'm going to take this, I'm going to take another color and remind you of the definition of conditional probability. Okay, and that's that the probability of B given EI is equal to the probability of B and EI divided by the probability of EI. Or we could say that the probability of B given EI times the probability EI is equal to the probability of B and EI. And this second version here is actually the one that's kind of the useful one, okay? So So let's keep that in mind and kind of put it over here in our mind palace. And what we're going to do is rewrite this over here as the sum of these elements here. So that P of B is going to be equal to the sum from I equals 1 to 7 of the probability of B given EI times the probability of EI. Great. Okay, so now let's pretend, so I chose 7 for a reason, because let's pretend that E1 is Monday, and then Tuesday, Wednesday, and Thursday, and Friday, and Saturday, and Sunday. Okay, so what does that mean? So it means what we've effectively done is taken this probability of B and said, well, that's the sum of the probabilities of B happening on Monday times the probability that it's a Monday. And so sometimes in your experiment, that might be a useful thing to do. Like, let's say you have this person has a schedule, and the event of interest can only happen during a certain period of time, and the schedule varies per day. And let's say that the likelihood of being on any given day is equal, so that's equiprobable, so this is just going to be 1 over 7. But the probability of B given EI, let's say him getting lunch, might be 0 on a Monday because he has a meeting. Okay, so on that day he has a meeting, so there's no chance. And maybe on Tuesday he finishes at 11:30, but then has a meeting at noon, so he needs his coworkers not to bother him so that he can rush over to the stand and buy his sandwich. And so maybe there's a 15% chance that his coworkers are going to leave him alone. So maybe that probability on that Tuesday is something that you can calculate. And so sometimes splitting it up, because you have the schedule. Now, sometimes splitting up a sample space into a partition makes those probabilities easier to calculate, because you can set up this equation. And you're going to see this equation pop up in other places, like Bayes' theorem, which is really important. It's important for machine learning, it's important for all sorts of other things, and I'll have videos on that as well. But essentially, that's the whole idea of a partition and why it's useful. It's, if you can't calculate the probability of something, maybe you can calculate the probability of something given you've chopped it up into bits that are more tractable. And so that's essentially the gist of it. And if anything was unclear, please say so. If you liked the video, please give me like an upvote and leave a comment, because it makes me feel good when I wake up in the morning. So have a nice day, and I hope that I have helped in some manner.